All right, let's look at the homework 9.5, problem number 9. All right, so this is an electric circuit problem. All right, so we have actually the differential equation is already given. So this is the differential equation we are looking at. All right, so let's plug in the numbers. All right, resistance. So this is going to be R. So here is R since it's a resistance. All right, capacitance is 0.05. So this is our C value right here. All right, and voltage is, let's say, constant voltage. So this is going to be E, is 40. And initial charge is 0. All right, so Q of 0 is equal to 0. All right, from there. All right. So let's put these numbers in. So it's going to be 5 dq over dt plus 1 over 0.05. So that's the capacitance. Then here's Q. And the right hand side is just 40. All right, so this is likely a linear equation, so we can solve it. So you can see that here, this is going to be 1 divided by 0.05 is 20, right? And since everyone seems to have 5 in it, so I'm going to divide through by 5. So we get dq over dt plus 4q is equal to 40 divided by 5 is 8. Right? So now we can see that this is going to be our P. Sorry, this is P of x. And this is just going to be Q of x. Right? So we can find the integrating factor I, which is e to the integral 4d x, so it's going to be e to the 4x. All right, then we know that we can find a solution Q, which is going to be 1 over I, which is e to the 4x, integral, right hand side is 8, times I e to the 4x dx. All right. Then if you do that, and 1 over e to the 4x, right, antiderivative of that would be 8 times, let's say, e to the 4x over 4. And then you have a plus some constant c. All right, so we can cancel 4 and 8 is 2. And then we can distribute this guy to each term. Then you end up getting, all right, so you have e to the 4x and e to the 4x cancel out, so you're going to have just 2. And then you have a plus some constant c over e to the 4x. All right, then we can use the initial condition, which is here, initial value condition. So we're going to have Q of 0 is equal to, if you put 0 there, so you have a 2 plus, e to the 0 is 1, so it's going to be c, and we're supposed to get 0. So which means that by subtracting 2, we can have value of c is equal to -2. All right, so we have, so the equation is going to be Q of t is equal to 2 minus 2 over e to the 4x. All right, we can actually rewrite it as pull out 2 and a 1 minus, and a 1 over e to the 4x is e to the -4x. All right, so that's the Q. So let's type it in. All right, so you have 2, 1 minus e to the -4 x, actually for t, sorry, instead of x. Right, did I use x? Yes, I did. All right, so maybe I messed that up. So this is going to be, all right, I use x all over the places, so it should have been t. Sorry about that. So here, that's t, and that's t there, that's t there, that's t there. All right, so you have a t here, and t here, t there, and the t there. And also those are t as well. All right, but let's double check. Submit for testing. All right, we got this one q correctly, and the current I, is just the derivative of the charge with respect to time. So all we have to do is I is going to be, just take the derivative of this guy, so it's 2. And the derivative of 1 is 0. Derivative of negative e to the negative 4t would be 4 e to the negative 4t. All right, which means that the 8 e to the negative 4t. All right, so let's type it in. 8 e to the negative 4t. All right, submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.